This equation has some different pieces to it. We have d equals VIT plus 1/2 AT squared. Sometimes you'll need to solve for VI, sometimes for A, and sometimes for T, but when we solve for T, either VI or A will be 0, so I'll walk you through both of them. Solving for VI, we start with d equals VIT plus 1/2 AT squared. So you have to remember here that you will know numbers for D, T, A, and again T. So this whole thing ends up becoming a number. So if we're solving for VI, I need to bring this whole thing over to the other side first. So I'll subtract this whole thing, 1/2 AT squared. I'll subtract that from both sides. If I have VIT plus 1/2 AT squared minus 1/2 AT squared, I cancel out that whole thing. And it'll give me D minus 1/2 AT squared equals VI times T. I'm trying to get the VI by itself, so I need to do the opposite to the T from what's already happening. Right now I have VI times T. The opposite is to divide that. So I'll divide both sides by T, canceling it out here. What that leaves me with is that VI equals D minus 1/2 AT squared divided by T. Remember that when you do this, you'll have numbers in all of these. T squared here and T might make you want to try and cancel something, but because the D doesn't have a T with it, you won't be able to cancel across the board. So you'll just leave it just like that, and you'll put your numbers in and solve. That's for VI. Solving for A is somewhat similar. Again, you start with D equals VIT plus 1/2 AT squared. And this time you're solving for A, so you need to subtract the rest of this over first. So you'll subtract both sides by VIT. Similar to what we did in the acceleration one. So on this side now you have D minus VIT equals 1/2 AT squared. There's a couple different ways that you can rearrange to solve for A. For simplicity's sake, I'm going to divide by everything that's not the A. So I'm going to divide by 1/2 T squared. That'll cancel out the half, it'll cancel out the T squared, and I'll do the same here, 1/2 T squared. There's other ways you can rearrange that, but you'll still get the final answer in the end. If you do it this way, you'll end with A equals D minus VI times T divided by 1/2 T squared. And when you're calculating this in your calculator, do this, get a number, do that, get a number, and then divide by those numbers. Order of operations becomes real sticky in here. So do the top, write your number down, do the bottom, write your number down, and get that from there. You may also need to solve for T. I will never have you solve for T if you have both a starting VI and an acceleration. In order to do that, you need the quadratic equation, and it gets quite messy. But there are times you'll have to solve for it when A equals 0 or when VI equals 0. So let's look at those. So if you have a problem that says that you don't have any acceleration, D equals VIT plus 1/2 AT squared, and A is 0, you're at a constant speed, you don't have any acceleration. Well, 0, if this becomes 0, 0 times anything is still 0. So you get rid of this whole part of the equation when A is equal to 0. So then you just have D equals VI times T. Well, if you want to solve for time here, currently VI and T are being multiplied. The opposite of that is to divide it. So if I divide by VI on both sides, I'm left with that T is equal to D divided by VI. Now this only happens if you're doing a problem where A equals 0. Another situation for this, same equation, D equals VIT plus 1/2 AT squared. Same equation, but VI equals 0. This one happens a lot because if you drop something from rest, that indicates that your VI is 0. So this whole thing goes to 0. 0 plus anything is just whatever was there. So you start then with d equals 1/2 AT squared. Well, if we're solving for t, the first thing I'm going to do, I've got 1 divided by 2 here. I'm going to multiply by 2 on both sides. 1/2 times 2, those cancel out. So I'm left with 2d equals AT squared. I'm solving for t. Currently, a is multiplied by t squared, so I'm going to do the opposite. I'll divide by a to keep t by itself, and that gets rid. So I have 2d over a equals t squared. And the last thing I need to do is remove the squared. The opposite of squaring something is to take the square root. So I have to do that on both sides. By doing this on this side, I have t that's remaining, and then is equal to the square root of 2 times the distance over the acceleration. That's the only time that that happens is when you're using equation 3 and VI is equal to 0.